So in part 2, we're going to look at the same function, f of x is equal to x over x minus 2. But what we need to address this time is the end behavior. So we already know or have established what it's doing around 2. What's it doing on the ends? And if you remember from our polynomial stuff, we talked about the degrees of the function and whether they're even and odd and all, starting above and ending below. But what happens with this? So we're going to build a table again, the same kind of table. This time, though, we want to let x get really, really big because we want to know what's going on out there at infinity. And we're going to let x get really, really small, what's happening out here at negative infinity. So let's do the right side first. So we're going to plug in 10. We're going to plug in 100, and we're going to plug in 1,000, and we'll plug in 10,000, and then we're going to plug in 100,000. So, okay, well, if you plug 10 into this function, that'd be 10 over 10 minus 2. That's 10 over 8. That comes out to be 1.25. When you plug in 100, you get 1.0204. Plugging in 1,000, 1.002. Plugging in 10,000, we get 1.0002. And when we plug in 100,000, depending on what you're setting your calculator to float the decimals as, we'll get 1.002. Again, I'm letting the calculator build the tables for me, or you can continue to plug in the number, it's your call. What we can say is this: well, as x approaches infinity, so as x gets bigger and bigger and bigger, well, what's happening to our y values? Well, it looks like our y values are getting closer and closer to the number 1. So that means at 1, out here at infinity, this thing is getting closer and closer to it. Well, that's a little different for us. Let's do the same thing on the left side and see what's going on. So we're going to come in and this time do the same exact function, but plugging in negative numbers. So we're going to plug in a negative 10 and a negative 100 and negative 1,000 and negative 10,000. And then a negative 100,000. Sorry, my table got a little squished there. Okay, if you plug in a negative 10, you get 0.83. So not very exciting. Plugging in a negative 100, and it's a repeating 3. You can carry more decimals if you want. When you plug in one negative 100, you get 0.9804. When you plug in a negative 1,000, you get 0.998. And now we can start to see something happening here. At negative 10,000, we're at 0.9998. And at negative 100,000, we're at 0.99998. So, and again, adding more zeros, you're just going to add more 9s on this thing. So what can we say about the left side? Well, as x approaches negative infinity, so negative infinity, what's happening to the y values? Well, it sure looks to me like the y values are getting closer and closer to 1 also. So this dotted line that we're drawing on this side is telling me that this graph is doing this kind of shape to it. So, and that's not a very specific graph. It's just giving us an idea that we've established what's going on in terms of the end behavior. So in the box is our conclusion. So as x approaches either positive or negative infinity, positive infinity, the r of x approaches a fixed number. The line y equal to L, so in our case, y equal to 1, is a horizontal asymptote. So it's an asymptote, but a horizontal one. It describes the end behavior, the line the graph approaches at each end. It does not tell us anything about what's happening inside. So it doesn't tell me anything about it here at all. It only tells me where it's starting on the left side and where it's ending on the right side. That's it. That's all it tells me. The graph can cross or touch a horizontal asymptote, and we will see examples of where it does. So we also have graphs that in place of that horizontal asymptote will have an oblique asymptote. Please note the graph will either have a horizontal or an oblique, never both. So how can we find the horizontal asymptote, the end behavior, without going through this process of building a table? Well, luckily for us, in our college algebra class, we can kind of do a shortcut method and take a look at cases. So what we're going to do, and this is in the box on your page, to determine the horizontal asymptote, we're going to look at the degree of the numerator. So remember, we're looking at P of x over Q of x. So we want to know what the degree of the P of x is, and we're going to compare it to the degree of the denominator, which is Q of x. So we have 3 possibilities. They're written on the page. I'm going to write them down just to make sure that the wording makes some sense to you. So case 1 simply says that P of x is less than Q of x. So this is what I consider to be a bottom-heavy function. So the degree in the denominator is heavier or larger than the degree in the numerator. If that's the case, then the horizontal asymptote is the line y equal to 0. That's the x-axis. That is not the one we just did. Case 2, what if they're equal to each other? Then the horizontal asymptote is the line y equal to, and it's the ratio of the leading coefficients, which is why we go do all that polynomial work first. So for our example that's sitting on the board, the leading coefficient in the numerator is a 1. The leading coefficient in the denominator is also 1. So what we're looking at for this one, because their degrees are equal, they're both to the first power, the ratio of the leading coefficients would be y equal 1 over 1, which is 1, which is what we ended up with. So we can see it in action there. And we'll do more of these in a bit. So. And then finally, case 3, the other one is what if P of X is larger than Q of X? So this is top heavy. Then what happens is your horizontal asymptote gets tipped. So instead of being a perfectly horizontal line, it gets tipped this way or this way, it gets tipped. So it's no longer horizontal, it becomes oblique. And you will do a division of the polynomials to find that. And we'll do an example of that one too. So that's how we go about finding the horizontal asymptote versus building a table. Okay, let's come in and talk about 2 specific rational functions. One we've already graphed. The second one we haven't graphed yet, but we're going to graph it here. So we're going to kind of switch gears. We've laid the groundwork on the asymptotes. Let's switch gears and do a couple of simple graphs. So specifically, when I'm going to graph f of x is equal to 1 over x, and we're going to graph f of x is equal to 1 over x squared. So 1 over x we've already graphed. This is example 2 at the top of the next page. We're going to be a little more specific than we did before. So we know that this is what we call the bow tie function. I'm going to plug in a couple of numbers. So if I plug in a positive 1, so what I'm really doing is building a table over here. We plug in a positive 1, 1 over 1 is 1, so I get a point right here. I need a couple more to give me a true shape. So I'm going to plug in 2. Well, that would give me 1 over 2, which is a half. So at 2, we're at a half. If we plug in 1/2, then we have 1 divided by a half, which comes out to be 2. So 1/2, we're at 2. So we can see it doing the shape we're expecting. So it looks something like that. Plugging in negative numbers, -1 going to get us -1. Plugging -2, we'll get a -1/2. And plugging in -1/2, we're going to get a -2. So it looks something like that. Now what's actually going on here is we do have those 2 asymptotes sitting here. Before, when we graphed this, we didn't draw them in. Now we're going to draw them in. So we have a vertical asymptote that's sitting right on top of this axis. I'm sorry, we have a horizontal asymptote that's sitting right on top of this axis. It's the line y equal to 0. It's the horizontal asymptote. Let's come back and make sure that all we've done makes sense to you. So when I look at the degrees, the degree in the numerator is a 0. The degree in the denominator is a 1. So it is bottom heavy, which makes it the line y equal to 0. So anytime you have a larger degree in the denominator, it's this x-axis or the line y equal to 0. Well, what about a vertical asymptote? Well, sure enough, there's a vertical asymptote, and it's sitting right through here. It's the line x equal to 0, because from the denominator, x can't be 0. What we're going to notice is that in both regions, the graph is starting next to an asymptote and ending next to an asymptote. Over in this region, it's starting by this vertical asymptote and ending by the horizontal asymptote. And there's the graph of that rational function with a little more detail than we did before. Let's go ahead and do the same thing with the 1 over x squared. So I'm actually going to talk about its asymptotes first. So when I go to look for the horizontal asymptote, I know that the degree in the numerator is 0. Degree numerator is 0. The degree in the denominator is 2. So again, this is smaller than this. So we know it's the line y equal to 0. So my x-axis is my horizontal asymptote. When we go to look for the vertical asymptote, that comes from the denominator and it's the domain restriction. So we can see that again, that x can't equal 0. So our vertical asymptote, sorry, it is a line. So I want to write it as a line, is x equal to 0. And that's coming from the denominator. Okay, let's plot some points just to feel a little bit more comfortable about what's going on. Although, you know what, I'm going to put the information we have down to begin with. Sorry, I'm playing with the markers, it feels like. So we have an asymptote sitting right on top of this axis. And we have another asymptote sitting on top of the other axis. Again, they're right on top of it. So this was y equal to 0. And the other one is x equal to 0. Okay. So plugging in some numbers, let's do the same exact y values, or I'm sorry, the same exact x values. When we plug in 1, 1 over 1 squared is 1. When I plug in 2, I get 1 over 4. If I plug in 1/2, I have 1 divided by 1/2 squared. That's 1 divided by 1/4. If I take 1 and multiply by the reciprocal, I'm going to get 4. So at +1, we still have those 2 points. But now at 2, we're down at 1/4. So notice I got closer to this asymptote quicker. And in terms of the other one at 1/2, we're up at 4. So I got closer to that asymptote quicker. Looks something like this. And again, you cannot touch that vertical one, and try not to touch the horizontal one because it doesn't in this case. Plugging in a -1 this time, though, 1 over -1 squared. Well, -1 squared is a +1, so I'm going to get a +1. So instead of being down in quadrant 3, it's up there in quadrant 2. When you plug in a -2, you'll get a +1/4. Plugging in a -1/2 is going to be a +4. Something like this. So I tend to call this the volcano function. So in this case, notice that they're both approaching the vertical asymptote, heading off towards in positive infinity. So I don't have one up and one down like we did over here. Whew, that was a lot, huh?